Dear students, now in this video we are introducing the third chapter of class 12, electrochemistry. Correct? So this one here, first of all, we will deal with its introduction. So let us see about the name of this chapter first of all. This is made up of two words. One is electro and other is chemistry. What it means? It means in this chapter we will only study about the mutual interaction of electric current and chemical reaction. Electric current and chemical reaction means how they mutually interact with each other. Number one. Number two, what are consequences related to it? Number three, in what way we can utilize all those? When all such things are discussed, then the total coverage is crowned with the name electrochemistry. Correct? So this mutual fighting between electric current and chemical reaction that will happen. Correct? And when we will have a fighting, we need a place of fighting. अगर युद्ध होगा तो युद्ध क्षेत्र भी होगा, and that device, that apparatus, that system where these two mutually interact, that is known as electrochemical cell. That is known as electrochemical cell. It is known as electrochemical cell. So this device, for what it is? It is for interaction between electric current and chemical reaction. So when we notice the working style of large number of electrochemical cells, then what we find that broadly they will be classified into two parts. Just here, this electrochemical cell, it is of the type, one is called electrolytic cell and the other is called galvanic cell. Both are electrochemical cell, but out of these two, one is called electrolytic cell and the other is called galvanic cell. Correct? These two differ from each other in respect of input and output. In respect of input and output. Let us see. Students, very clearly we can differentiate between these two. See, input and output. In electrolytic cell, input is current and output is chemical reaction. Input is current and output is chemical reaction. What it means? That they are those chemical reactions which are only possible when reactants suffer flow of electric current. So they are electrochemical reaction and they occur in electrochemical cell, and that electrochemical cell, it is known as electrolytic cell. And apart from these, there is some other type which is known as galvanic cell, in which what happens, there is input is chemical reaction and output is current. Input is chemical reaction and output is current. Actually, from very beginning it's known to you that electric current, when it flows, it is due to movement of flow of electrons. And traditionally what is assumed, that if electron flows in this direction, the current flows in this direction. Conventionally it is assumed. Correct? Means movement of hole in the direction of movement of current. So here, this is a chemical reaction where there is what type of thing happening? Flow of electron. And students, very clearly it's known to you from class 11 that when there is exchange of electron in a chemical reaction, then that chemical reaction is known as what type of reaction? It is of the type redox. Redox chemical reaction. Correct? All type of chemical reaction are not capable to give current in a galvanic cell, but only those chemical reactions where there is flow of circulation of movement of electrons can only give current, and that device is known as galvanic cell. That device is known as galvanic cell. Correct? So this is about the working place of all the things which are present in electrochemical cell for our discussion under the heading chapter electrochemistry. Correct? After that, and I think input and output, they are very clearly known to you. When something is given, which is the cause, it is input. And when after giving input something is gained, that is known as output. As for example, when electric current is given and bulb gives us light, so input is electric current and output is light. In a ceiling fan, input is electric current and output is mechanical work, movement of the blades. Correct? So in this way, inputs and output, they are very clearly known to you, and these two type of electrochemical cell can be classified very easily, can be distinguished very easily, can be understood very easily on the basis of this input and output. Okay? After that, now come to when the word cell it is used, then generally in your brain such type of figure is created like this. Correct? So from here circuit is closed, from here current flows, comes here, here, and then comes here, and here for making the circuit close, current also flows in between these two electrodes. Correct? Now, let us see, from here to here, it is moving through metallic rods or plate. From here to here, loose wire, and then again from metallic rod or plate. Correct? But here they are moving through solid. They are moving through solid. But in between this point and this point, let us mark A and B. So in between A and B, this current is moving through, generally a student answer, liquid. Correct? Even in competitive exams, when such type of question comes with diagram and it is asked in between A and B, current is flowing through, first option given is liquid, which is wrong. Here current is not moving through liquid, but it is moving through electrolytic solution. It is moving through electrolytic solution. Electrolytic solution. Therefore, on the basis of the medium by which current is moving from one place to another in a device, we can give two different names to such type of movement of electric current. When it passes through solid, it is called metallic conductance. It is called metallic conductance, and when it is passing through electrolytic solution, it is called electrolytic conductance. So, on the basis of this medium of movement, the pathway adopted by electric current during the complete journey, the two terms are now very much clear to us: metallic conductance and electrolytic conductance. Dear students, in CBSE exam, 2-mark question is asked: difference between metallic conductance and electrolytic conductance. So let us see. Difference between metallic conductance and electrolytic conductance. Dear students, again and again, every time I suggest you that whenever you are going to answer any question which is difference between or differentiate, then always answer in tabular form. So what we will do, we will divide the page into two parts. One side we will write metallic conductance, and in other side metallic conductance and electrolytic conductance. Correct? Now, first point, in metallic conductance, current passes through solid. So here current passes through electrolytic solution. Passes through electrolytic solution. Number 2. In this case, electrons are carrier of current. That is, there is in metallic conductance what happens from one place to another place, current moves due to free flow of electrons. Electrons are the carrier of current. Here, ions are carrier of current. Ions are carrier of current. Correct? Third, here only current moves, but not the quantity. Correct? Only current moves from one place to another place, but there is no movement of mass. Every atom of the solid remains intact exactly at its lattice point. But here, movement of mass is a must. Movement of mass is a must. Certainly it will move. You can see it. Just go to any soap in the market where there is, but not in this lockdown period. And so many batteries are dismantled. You will find that electrodes are very dirty. So from where all the dirt came? Really, quantity flows from the solution and it gets collected on those electrodes. So not only current moves, but due to flow of current, even quantity also moves. In the similar way, when there is flow of water in the river, along with this flow of water, certain quantity of sand also moves. Sand particles also move through water. In the similar way, here also movement of mass occurs along with the flow of current. differentiate between these two. Correct? After that, then come to a term a specific conductance. A specific conductance or conductivity. Either you call it a specific conductance or you can call it conductivity. Correct? So in this way, this name is very traditionally, not as a rule, traditionally this name is very much popular in chemistry and this is very much popular in physics. Have got a symbol kappa or k, a small k, like this. Correct? Suppose in a metallic wire current is flowing, then what is practically found that R is proportional to L. R is proportional to L, where symbols have their usual meanings. Here R is resistance and L is length of wire through which current is moving. Correct? And this R is also proportional to 1 upon A, where this A is cross-sectional area of the wire. I think in class 9th or 10th also you had gone through this in physics. So R is proportional to L upon A, or this R is equal to a proportionality constant rho into L upon A. Or you can place it like this: 1 upon rho is equal to 1 upon R into L upon A. This rho, 1 upon rho is called K or kappa, and this reciprocal of resistance, it is conductance C into L upon A. Students, this one is this K, it is conductivity or a specific conductance. This is conductance, and for a particular cell, this fraction L upon A, it is called cell constant. It is called cell constant, and this one is called a specific resistance or a resistivity. This one, it is a resistivity. Correct? So if we want to have a definition of this, then let us see how it can be done. If this one is 1 and this is also 1, this total will be 1. In that case, what will happen? This will become equal to C. So this is the base for defining this one. That is, quantity or magnitude of current passing through a wire of unit length and unit cross-sectional area is known as a specific conductance or conductivity. Or if a length is 1 and area is 1, what it means? It means volume is 1. So the magnitude of current passing through while having unit volume is known as a specific conductance or conductivity. But dear students, notice it very minutely that both the definitions are applicable to current flowing through solid. Suppose if there is electrolytic conductance, means if current is flowing through electrolytic solution, then their ions are the carrier of current. So what is defined? Definition of that, that is, let us imagine 1 ml. 1 ml means 1 centimeter cube of volume of that solution. That will have some number of ions. Ions means cations and anions both. Correct? So the total conductance carried by all the ions which are present in a unit volume of that solution is known as a specific conductance. It is known as a specific conductance. Correct? After that, now come to the second one, which is called molar conductance. Next is molar conductance. Its symbol is lambda m. Lambda m. Actually, generally, students, you are familiar with this lambda. So you will be making a doubt that from where this lambda came. Actually, this is also lambda. Difference is it is small lambda and it is capital lambda. Okay, no problem. Then come to the term molar conductance. Actually, we have solution, electrolytic solution in our hand. So suppose we have a solution in which 1 mole of electrolyte is dissolved, and that is giving conductance, that is known as molar conductance. Means the total conductance given by that volume of solution which contains 1 mole of solid or electrolyte dissolved in it is known as molar conductance. Correct? So all the time we don't have solution in which 1 mole is dissolved. So what we will do? Suppose let x mole of solute is present in 1 liter of solution. Then 1 mole of solute will be present in 1 upon x liter of solution. So dear students, this 1 upon x liter, what it is? It is the volume of solution in which 1 mole of solute is present. And if that solution will give some conductance, that is known as molar conductance. That is known as molar conductance. So let us see how we can, this liter, or even you will call it this milliliter of solution. So mathematically you can represent as lambda m, it is equal to, now if we have 1 ml of solution, solution? Conductance given is a specific conductance. This multiplied by total volume means 1 upon x liter. Then this is one formula. Or lambda m is equal to k into this is second formula, which can be used for solving numericals. That is, for a particular solution, when we have known value of this, and out of these two, one is really known, other we can get. Now, dear students, can you predict what is this x? Recall your memory to the definition of different concentration which we had studied in previous chapter, solution. But it is x is what? Moles of solute dissolved in 1 liter of solution. Obviously, what it is? It is molarity. X क्या है? Where this x is molarity means when in numerical molarity of the solution is given, and out of these two, one will be given, second we can calculate very easily. Okay, so students, here we have studied about introduction of electrochemistry, then two type of conductance, metallic and electrolytic conductance, and then further to a specific conductance and molar conductance. Correct? Thank you all in this video. Okay.